So today I want us to begin with decision making. And I want to discuss that. Thank you. You can see. And I want us to discuss that using a question that was tested in June 2013. Question 3B. June 2013, question 3B. June 2013, question 3B. Have you seen the question? So we have seen the question, and the question reads, the following pair of matrix shows the potential profit and losses in millions of shillings, which are expected to arise from launching 4 new products, P1, P2, P3, and P4 in 5 market conditions. Which are M1, M2, M3, M4, and M5. Now, assuming that the products are mutually exclusive, evaluate the best decision using, So, anytime you read a question on decision making, I hope it is that question. I've said the question of 3B. Yes, 3B, yeah, good. Part A is on game field, 3B. So when you come across that question, the very first thing is to know the objective. Objective is the purpose that you want to achieve. Now, this company, which is trying to launch new products, they are obviously going to maximize profits. So the first step is to know the objective of the question. So the objective is to maximize profits. The objective is to maximize profit. And as soon as you write profit, it is important you write how profit is arrived at. Profit is equal to revenue minus cost. Revenue minus cost. That's the first step. The second step is to know what are the options. What are the options? Options, it is what you can control. So in this question, the options available are the products. The products. The product, which product to produce, it is within control of the decision maker. Step number 3, you identify the outcomes. You identify the outcomes. Now, outcomes, they are also called states of nature, because they are beyond control of the decision maker. They are beyond control. So what is beyond control here is market conditions. It's market conditions. That is beyond control of the decision maker. The next thing is to know the type of the decision that you're dealing with. The type of the decision that you're dealing with. We have two types of decisions. One is called single stage. The other one is called multiple stage. Now, single is when in the options you just have one, and in the outcomes you just have one. So this one is single stage. This is called single stage. Then from there, after you know the type, you now compute the payoffs. You compute payoffs. Now, payoffs is the other word for profits. Is the other one for profits. You compute the payoffs now, you come up with a formula that will give you that. After you compute the payoff, like now in this question is already provided. For this question, it is already provided. So we are not computing. It's already provided. Then from there, you prepare a summary. You prepare a summary. You prepare a summary. When you are in the single stage, the summary is called payoff table. It's called payoff table. Payoff table. And in this question, it is already provided. It is already provided. That question is already provided. The payoff table is already provided. So what we are going to do, I think maybe we can we can copy this one because I want to use it to take you through all the steps that are used in a single stage. So I want us to copy that, the summary. So the payoff table so there are 5. So this is M1, M2. Sorry, these are, I want to put the options on this side. So this is P1, P2, P3, P4, P5, and then I might create probabilities. I might create probabilities. So this is M1, M2, M3, M4, M5, and then I might need something called expected monetary value. So these values, the way they are given, if I follow P1, oh, there are 4 P's. There are 4 products. So it's so then this one should be my probability. Not there are 5, 5. So if I follow P1, it is 15, 3, no, 15, 10, 0, minus 6, and 17. If I go to P2, I have 3, 14, 8, 9, 2. P3, I have 1, 5, 14, 20, minus 3. P4 is 7, 19, 10, 2, 0. I've interchanged rows and columns so that it looks the way I want. We are not given the probabilities, but there are some questions that will be given. So for the purposes of our discussion, I want to assume probabilities so that I am able to take you through everything in the single stage. So this one I can give it 0.05, this one 0.1, 0.15, 0.3, 0.4, and this will be 0.1. It's already 5. Yeah. So these probabilities, I have assumed them. They were not part of the question because I want to do everything. But okay, so if that is okay, we go on to the next step. The next step now after the summary is make a decision using appropriate rule. Appropriate rule. You make a decision using appropriate rule. So there are several rules that are supposed to be used. And I'll not just confine myself to what the question is asking, but I will take you through all. So the first one is called most likely event rule. Most likely event rule. Most likely event rule. So this most likely event rule is used where the names of options, I needed to have done this here. These ones are the options, and these ones are outcomes. Options and outcomes. So the names of outcomes here in M1, M2, M3, M4, and 5 should be the same or should be similar to the names of options. You can see this is P1, P2, P3, P4. So now that the names are not similar, this rule cannot be used in this area. So this rule cannot be used. So here we will say not applicable. It's not applicable here. Not applicable here, since names of options, names of options and outcomes, and outcomes are not similar. Are not similar. So that one cannot be used there because the names are not similar. But if the names were to be similar, you go with the one that has the highest probability. And for more, you'll be able to see in the book, I think I've illustrated. So that is rule number one. Let's go to rule number two. Rule number two, that was number one. Number two is called expected monetary value rule. The EMV, expected monetary value rule. Yes, the probabilities were assumed. They are not part of the question. Yes, because I want to use them to illustrate everything. Is that okay? Okay, good. It's okay, that's good. So the expected monetary value rule, we normally arrange it like this. We have the option here. Then now we compute the expected monetary value. The expected monetary value. So P1, you take these pairs the way they are, that is 15 multiplied by the probability down here, 0.05, plus 10 multiplied by the probability here, 0.15, plus 0 multiplied by the probability, 0.3, plus minus 6 multiplied by the probability, 0.4, plus 17 multiplied by the probability, 0.1. Then you come to P2. P2, it is 3 times the probability here, plus 14, you multiply by the probability here, plus 8 multiplied by the probability, 0.3, plus 9 multiplied by the probability, 0.4, plus 2 multiplied by the probability, 0.1. You come to P3. P3 is 1 multiplied by 0.05, plus 5 multiplied by 0.15, plus 14 multiplied by 0.3, plus 20 multiplied by 0.4, plus minus 3 multiplied by 0.1. And these are the one, P4, it is 7 multiplied by 0.05, plus 19 multiplied by 0.15, plus 10 multiplied by 0.3, plus 2 multiplied by 0.4, plus 0 multiplied by 0.1. So now you take your calc and multiply. You can be giving me some figures. That is 15 times 0.05 plus 10 times 0.15 plus 0 times 0.3 plus minus 6 times 0.4 plus 17 times 0.1. I'm getting 1.55. I got the next one, 3 times 0.05 plus 14 times 0.15 plus 8 times 0.3 plus 9 times 0.4 plus 2 times 0.1 is 8.45. 1 times 0.05 plus 5 times 0.15 plus 14 times 0.3 plus 20 times 0.4 plus minus 3 times 0.1, 12.7. 7 times 0.05 plus 19 times 0.15 plus 10 times 0.3 plus 2 times 0.4 plus 0 times 0.1 is 7. So are we okay? I think you can try speaking. I'm very close to the speaker now.
Yes, yes.
Okay, good. Yeah. So if we are okay, now this one, you select the highest. You select the highest of all. So the highest of all is this one. So we circle that way. And that means the advice that we are going to give, the advice is that they should produce, they should round product P3. So we are going to tell our client that they should round P3, product P3. Then these values, we will copy them here because we will require them later on somewhere. We will require them later on somewhere. And maybe this one I needed to have added expected monetary value without information. Without information. Without information means you have not been told which one will exactly come to be. So you're just chancing. You are looking for everything. And you see the difference when we say with information. So can I wrap this one now?
Yes, 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 bro.
Good. That was rule number 2. Now, those 2 rules, they are not part of the question. So now we can try to answer the ones in the question. The first one is Raprez rule. Raprez. So we are in rule number 3. That is number 3 now. Need to number them so that I don't forget the number what. So this is number 3, which is called Raprez rule. And Raprez rule, it is also arranged like this. We have the option here. Then we compute something called simple average. Simple average payoff. And simple average payoff for P1, what you do, you take the payoffs 15 plus 10 plus 0 plus minus 6 plus 17. All these you divide by 5 because there are 5 of them. That's simple average. You come to P2. You take 3 plus 14 plus 8 plus 9 plus 2 you divide by 5. We go to P3. We take 1 plus 5 plus 14 plus 20 plus minus 3. You divide by 5. Then there is P4. That is 7 plus 19 plus 10 plus 2 plus 0. You divide by 5. So when you do that, it will be 15 plus 10 plus 0 plus minus 6 plus 17 equals, divide by 5, I'm getting 7.2. I have 3 plus 14 plus 8 plus 9 plus 2, 36, divided by 5 is 7.2. Again, I have 1 plus 5 plus 14 plus 20 minus 3. Divide by 5 is 7.4. Then 7 plus 19 plus 10 plus 2 divided by 5 is 7.6. So even this one, what you do now, you select the highest. You select the highest of these simple averages. So the highest is this one. So you are going to advise that they round product 4. You are going to advise that they round product 4. Is that okay?
Yes, yes, brother.
Are we okay with that? I move to the next.
Yes, yes.
Good. That was number 3. Let us go to the next one. They are calling it max-min criterion. That is rule number 4. Max-min criterion. Criterion is the other word for rule. So what you do, you have the option here, and you can see this rule is divided into 2. There's a makeup of 2 words. There is the word maximum and the word minimum. The word maximum and the word minimum. So you extract the minimums. The last one here, you extract those pairs. So we are going to extract the minimum pairs. So here I will have minimum payoff. So in option B1, the minimum, when you run through here, the minimum is -6. Option B2, when you run through here, the minimum is 2. Option P3, when you run through this, the minimum is -3. Option P4, when you run through it here, the minimum is 0. That's the first thing, you extract the minimums. Then this rule is interpreted like this. Select the maximum of the minimums. Select the maximum of the minimums. So the maximum of these minimums is 2. So when we are using this rule, we will advise them to round product P2. And what you should notice at that point is that different rules are giving us different advices. And that's the reason why people never make the same conclusion given the same data or the same environment. Because it depends on which rule someone is using. So if we are using different rules, chances are we will make different conclusions. Yeah, so when you see someone making a different conclusion from yours, don't be quick to call them fools. Please understand that they could have used a different rule than the one that you have used. They only become fools if they have used this rule and they have not selected two. That's when now you can say that person is a fool. But as long as they have used that rule and they have used it correctly, they are okay. Okay, is that okay, Mohammed?
Yes.
Good. So we move to the next. The next one is min-max regret. Now, before I handle that, I want to illustrate another one. Which I want to call number 5, which we call max criterion. Now, max, as I've said, you extract the pairs that are the second one here. The second one is maximum. So I will go to the payoff table. I will go to my payoff table and extract the maximums. So the maximum. So P1, when I run through it, the maximum is 17. When I run through P2, the maximum is 14. When I run through P3, the maximum is 20. When I run through P4, the maximum is 19. So this rule is interpreted like this. Select the maximum of the maximums. Select the maximum of the maximums. So the maximum of the maximums is this one. So I will advise them there that they should select product P3. They should select product P3. Okay. What you can also gather from those two rules, number 4 and number 5, we are connecting two words, max and min. So we already have had max-min and max-max. You can also have min-max. That can also be a rule. Now, if you are told to use min-max, you will extract the minimum, min and the maximums. These maximums. Then you will say, select the minimum of the maximums. Select the minimum of the maximums. So the minimum of these maximums is this 14. You can also be told to use min-min. That's also another rule. Min-min. So if you are told min-min, you will extract the minimums, then go to that column and say, select the minimum of the minimums. Select the minimum of the minimums. The next rule is number 6. Number 6 is called Howitz. And here we are told alpha to be, alpha is 0.1 minus alpha is 0.1 minus alpha is 0.35. 0.35. So that means alpha must be 0.65. That means that one they are given in the question. It means that alpha must be 0.65. So what we do with this one, we have the option here. Then you take alpha times best payoff plus 1 minus alpha times worst payoff, and that gives you something we call weighted average payoff. That is how it is computed. You take, so when you come to P1, alpha is 0.65. The best payoff for P1, it is 17 as the highest. 1 minus alpha is 0.35 times the worst there is minus 6. Then I come to P2. P2, I take 0.65 multiplied by the best. The best here is 14 plus 0.35 multiplied by the worst. The worst for P2 is 2. Then I go to P3. 0.65 multiplied by the best there is 20 plus 0.35 times P3, the best is minus 3. Then P4 is 0.65 multiplied by the best here is 19 plus 0.35 times the worst here is 0. The worst is 0. So seeking help from the calc, I will get 0.65 times 17 minus 0.35 times 6 is 8.95. 0.65 times 14 plus 0.35 times 2 is 9.8. 0.65 times 20 plus 0.35 times minus 3 is 11.95. 0.65 times 19 plus that will be 0. 12.35. So with that, what you do, you again select the highest. The highest of all these, is 12. So you will advise them that they go for product P4. So are we okay at that point?
Yes.
Okay, good. So I want now to go to the next rule. That is number 7. So that rule requires that we create another table. So I'm going to create a table here. Before we go to those other rules, it requires we create a table called opportunity losses. Opportunity losses, they are also called regrets. Regrets table. One, two, three, 4, 5, 6. So in this one, we have P1, P2, P3, P4, and the probabilities. So we go to M1. So what you do, you pick the highest value for M1, the highest value. The highest value is 15. And you record it everywhere here that way. Then you minus the other values. So minus 15, minus 3, minus 1, minus 7. So this one gives us 0, this gives us 12, this gives us 14, this gives us 8, and the probability is 0.05. That is M1. Then you go to the second outcome, M2. When you go to the M2, you pick the highest in this column. The highest is 19. So you record it everywhere this way. Then you subtract the others. So the others are 10, 14, 5, and 19. And you tell us this is equals to 9, this is equals to 5, this is equals to 14, this is equals to 0, and the probability is 0.15. Then you go to M3. M3 do the same. The highest there is 14. 14, 14, 14. So you subtract the others. The others are 0, 8, 14, and 10. So this is 14, this is 6, this is 0, and this is 4, and the probability is 0.3. Then you go to M4. In M4, the highest is 20. So you say minus. Minus 6, 9, 20, and 2. So this becomes 26, this becomes 11, this is 0, this is 18, and this is 0.4. Then we go to M5. M5, the highest is 17. The highest is 17. So you say minus 17 to minus 3 and C. So this is 0, this is 15, this is 20, and this is 17, and the probability is 0.1. Then you compute something we call expected opportunity loss. Expected. Are we together up to that point? Are we together? Good, good. So that is how you compute the opportunity losses or the regrets. So we want to compute the expected opportunity losses. And I will not write because it is exactly like what we did with expected monetary value. You take these values, you go multiplying with the probabilities as you act. So I'm hoping you'll be able to follow that. It is exactly what we did with expected monetary values, how we got these ones. So if that is okay, let's begin. Tukianza na hii ya kwanza, it will be 0 times 0.05 plus 9 times 0.15 plus 14 times 0.3 plus 26 times 0.4 plus 0 times 0.1 equals. And the answer is 15.95. 15.95. I repeat, I do now for P2. So it is 12 times 0.05 plus 5 times 0.15 plus 6 times 0.3 plus 11 times 0.4 plus 15 times 0.1 equals 9.05. The next one is 14 times 0.05 plus 14 times 0.15 plus 0 times 0.3 plus 0 times 0.4 equals 2.8. 8 times 0.05 plus 0 times 0.15 plus 4 times 0.3 plus 18 times 0.4 plus 17 times 0.1. I'm getting 10.5. I'm getting 10.5. So I think in our rules, we had gotten up to number 6. So I think now I should be going to number 7. If I have not skipped. So number 7, rule number 7 is the one they are calling min-max regrets criterion. So min-max regrets criterion or rule. So this one, just like I told you with the others, you look at the last one here. The last one is max. So we are going to have the option here, and then we extract the maximum regrets. The maximum regrets. The maximum regret. So option P1, P2, P3, and P4. So now you come to the table of regrets. You come to the table of regrets. So in this table of regrets, P1, the maximum regret is 26. It's 26. P2, the maximum regret is 15. P3, the maximum regret is 20. And P4, the maximum regret is 18. So just like we did with the others, this means select the minimum of the maximums. Select the minimum of those maximums. So the minimum of those maximums is this, and therefore we advise that they should round product P2. They should launch product P2. Rule number 8. Rule number 8 is called savage. Some people also call it regret rule. Regret rule. Savage or regret rule. So this one, you again get the option, and then you have to compute the expected opportunity losses, which we already have done. So P1, P2, P3, and P4. So P1, you pick these the EULs that you already have computed. So this is 15.95. This is 9.05. This is 2.8. This is 10.5. So what you do, you now pick the smallest. These are losses. So for losses or regrets, the ones that people say, I wish I knew, you pick the smallest. So the smallest is this one. So the advice is you round P3. So I hope we are together at that point. The last thing that I want to show you as far as the CGOs are concerned, is called value of information. Value of information. Now, value of information is given as the expected monetary value with information minus the best expected monetary value without information. These things, the formulas, you can clearly also find them in my book. They are well illustrated. So, with information, what you do, someone who has information does not waste time. They know what to pick, and they go picking for the best. So, you come to the original table, the payoffs table. In M1, you pick the best. The best is this 15. So 15 times 0.05 plus, when you come to M2, the best is 19 times 0.15. When you come to M3, the best is 14 times 0.3 plus M4, the best is 20 times 0.4. When you come to M5, the best is 17 times 0.1. Then you minus the best of these EMVs. These are the ones we encode without information. You minus them. You minus the best. The best was this one, 12.7. 12.7. And the answer you get should be equal to 2.8. Because the other formula for getting value of information, it is the lowest EUL, this one. But we can confirm whether that is true. So ukichukua calculator useme 15 times 0.05 plus 19 times 0.15 plus 14 times 0.3 plus 20 times 0.4 plus 17 times 0.1 minus 12.7. I'm getting 4.8. I really hope this one was computed well. So this is giving me 4.8. Maybe you can recheck whether that one was computed well, because they should agree. So that is how you compute a value of information. So are we together at that point?
Yes, brother. I didn't understand your question.
You didn't understand the.
No, I understood it, but I am seeing there's a difference between 4.8 and 2.8. Maybe I will get back to it when the lesson ends. This regret rule opinion and also value of information. You said they should get the same answer, but I'm seeing different answer. I will get back to it this one later on. I'm seeing the one we did now is right, but the regret maybe we didn't do
Or
it
the
right.
regret
So
is the
I'll
one
get
that
back
has
that is what I'm thinking.
okay. But basically, you understood how we developed the table here?
Yes, very much.
Okay, then once you have the regrets, those are called the opportunity costs. You pick the maximum from each option. These ones. These are the maximums from each option. Then according to this rule, you should pick the minimum of the maximums. So the minimum of these ones is 15. Then for this one, this is called savage or the regret. It's very similar to this other one. But now this one uses the expected opportunity losses. And the expected opportunity losses, I have said we get them just like we got the EMV. You multiply those regrets by the probabilities here as you add. So maybe you will recheck because this one already has highlighted us to us that there is somewhere I made a mistake. Maybe you need to check on that because I've already wrapped the table. Is that okay?
Yes, very much.
Good. Now, what I have given you is everything you can be asked as far as the single stage decisions are concerned. As far as the single stage decisions are concerned. But now in an exam setup, you only answer the ones that are required. But because for me, I don't know what they bring in the exam, if they will, I have to show you everything.
Very good.
That being okay, I want to point to you another question, which if time allows, we can design. On your own, you can try this one. The question of May 2021. May 2021. Question 2C. Now that one you just answer what is provided. I'm looking for another one. There is another one I know that is like to attempt, or I've seen it. September 2021. I think you can also check September 2021. Question 4C. So, because you already have the solutions in the book, I think it will be easier to understand now to see how whatever is there is arrived at. But in case of any problem, you can always let me know. Is that okay?
Yes, brother. Yes, brother. I always get back to the answers from the book.
Okay, good. So I think then we can call it a lesson at that point. Then when we meet next, we shall do the multiple stages decisions. Is that fine?
What did you say?
I've said we call it a lesson at that point.
Yes.
Yeah, so that now next time we shall discuss the multiple stages decisions.
Thank you so much.
Thank you. Have a good day.